Okay, so question 5H1 from the second edition of Statistical Rethinking. If you're going to run any of this code, make sure that you have installed and loaded the Rethinking library. Those first two code blocks up there in the Colab sheet. Okay, where are we at here? So now the content is starting to get into some things that I find fun and interesting. The question asks us to go back to the waffle divorce data set, and the model for divorce is being predicted by marriage and marriage rate and age, I believe, M and AR, and D being divorce rate or divorce. Okay, and we are supposing that the DAG is this pipe here. M affects A affects D. Okay, and so what it asks us to find the implied conditional independencies of this graph here, of this DAG, and then to evaluate our data and ask, is our data consistent with that DAG? Now remember, a DAG is a causal graph that embeds our assumptions about the causal relationships among the variables in our problem. Okay, so I'm going to start by building this DAG in R because the DAGD package allows us to do some cool things with DAGs. So here I have the library DAGD that I'm loading. I'm defining a DAG that I'm calling div DAG for divorce, and so here's my DAG. I just plot the coordinates of M, A, and D for X and Y, and then I'm going to draw the DAG here. Okay, so I've just recreated the same DAG as described in the problem. Okay. Just to point out that you could also do this at dagd.net. So when you go to dagd.net, you'll navigate to a screen like this. Actually, let me you'll actually navigate to a screen like this, and when you click here, you'll get to this screen. Okay. So I've built my DAG, and so we can also build it here. I'm going to come back to this screen because there's some cool things here. Okay. So first we need to find the conditional independencies that are implied by this DAG. Okay. So what does it mean for two variables to be independent? Well, technically what it means, so I have some discussion here, but that the joint probability, so X and Y, or in our example, M and D, that the joint probability of values for these variables is the same as the product of their variables, or of their probabilities. Okay, so that's a little bit of a technical thing. You can read more about conditional independencies with a link that I've put here that goes to a free online textbook. It's a very good textbook. So if you're interested in probability, I suggest you read it. But we can think of independence as knowing about one variable, X or M, does not tell us anything about the other variable, Y or D in this case. Okay, that's what we mean by independence. We can also think about it as X and Y, or M and D, don't share information if they're independent. Okay, we can think about it in all those ways. So two variables are conditionally independent if we can't say anything about the two variables. So let me just use an example. So if I can't tell you anything about Y, even though I know things about X, as long as I know Z. So translating it to our DAG here, if M and D are conditionally independent, it would mean that although I may be able to tell you something about D if I know something about M, the amount that I can tell you about M and D, or there's nothing more I can tell you about the relationship between M and D if I also tell you about A. Okay, so that's kind of a mouthful. But in other words, with a DAG, one of the things that DAGs allow us to do is to get a more intuitive sense of what's happening here. So a DAG again is encoding information that's being shared among all of the variables, and M is sharing information with A, and A is sharing some of that information again with D. Okay, and hence our DAG here. And so we can, if M and D are conditionally independent, that means that by conditioning on A, I block the flow of information from M to D, in which case M and D would be conditionally independent given A. All right. So we should predict then that M and D are conditionally independent given A, according to our DAG. Okay, well, when DAGs, so in this case it's kind of simple, but when you get really complicated causal structures, there's some tools that can help us out. And one is this implied conditional independencies command from the DAGity library, which was loaded already up here. So if I click on that, I get this little readout. So this is akin to this little perpendicular sign here. So D is independent of M given A, right? And that's what we have here, except for they've just reversed D and M. The order doesn't matter there, okay? So DAGity pulled out the conditional independencies implied by the DAG for us, okay? We can also get that at dagity.net. So once I have filled all of this in, it gives us testable implications, and it says M is independent of D given A, which is what we have found now in two different ways. Okay. One of the useful things then about DAGs and about these implied conditional independencies is that they can be a test for our model, right? So remember, the model that we come up with, like this, are represented by the DAG, there's nothing to tell us that it's correct. We have to use our subject matter knowledge and expertise to say what we believe that these relationships are. Okay, but we can be wrong. Just because we've assigned a DAG to something to our problem does not mean that reality actually follows the relationships put forth in that DAG. Okay, and so we want to test our DAG against the data. All right, and so what this means is that in our data, these conditional independencies make for very good testable implications. So if we have an implied conditional independency that D and M are independent given A. So that means that when I go into my data, I should be able to find that relationship, right? I should be able to find that M and D are related until I also consider A. Okay, and that's what we're going to do here in a second. But I just want to point out a couple of things here. So we're going to do that with regression, and you'll see how that works. But in practice, it's not clear cut. There's generally not something that says, yes, these are independent. Yes, these are not independent. Instead, what you get are estimations of associations between variables. And those associations are just estimates, and they cover a range of values. And the only value that truly means independent is 0. But you're going to get a range of estimates that may or may not include 0 or put a lot of probability weight on 0. And so generally what we're looking for is a beta coefficient that encompasses 0, or that the estimate for the beta coefficient in the regression, remember the beta coefficient is the association between a predicted variable and the outcome. We're looking for that value to be 0 for it to be independent, conditionally independent on everything else in the regression. And for the credibility interval to more or less spread pretty evenly around both sides of 0. Okay, so there's that. Another reason that this is tricky is because just because your DAG, that the implied conditional independencies of your DAG are present in the data, that does not mean that your DAG is correct. It just means that you have not demonstrated that it's false. Okay, there's often many DAGs or models that can fit the data. Again, the way that we arrive at our particular DAG is based on information that is outside of the data. It's based on subject matter knowledge, or expertise, or hypotheses, or whatever, right? But the DAG itself is not present in the data. We impose that, and we can be wrong, and so we can propose a DAG that is not a good model, and yet its implied conditional independencies are found in the data. Okay, so it's all very treacherous. Anyway, we're asked to determine if this conditional independency is actually present in our data. So in order to do that, I'm going to rerun models M52 and M53 from the chapter. Okay, M52 just it conditions, or it's trying to find the association between D, the outcome variable, and M. Okay, and that association is represented by the beta coefficient Bm here. Okay, and the next model M53 has M again, but also includes A. All right, and so if that implied conditional independency is actually a feature of our data, we should see that in the first model, the Bm, the beta M, is not 0, right? That we find an association between M and D, but then that association should dissipate or disappear once we additionally condition on A. That's what we should find, okay? So all of that, and so here's our summary outputs for the first one for M52 and then M53 on the bottom. And so if we go to the first one for the beta coefficient on M, right? So we see that its estimate is above 0, and not only is it above 0, but its credibility interval, here it's 89% credibility interval, seems to be safely on one side of 0, right? So this suggests that there is a meaningful association between M and D, okay? And so that's good. That's consistent with our DAG. And then the next test here is after we condition on A, then the association with M and D should drop towards 0. Okay? And in fact, that's what we see here, right? So now all of a sudden the beta coefficient for M, where it was safely positive, has now dropped towards 0, goes a little bit below 0, but again, these are just estimates, so don't overread into those. And the credibility interval now semi-evenly covers 0. And so this is pretty good evidence then that our DAG is representing our data, right? Okay, that is it for this one. Thanks.